Right, so we're going to start looking at the fuel system now. We're going to be running a slightly different setup on this engine to what I was before, because obviously before we were just running the mechanical pump. So that obviously sucked its own fuel up from the tank, although we did have a lift pump with a pressure egg, but it was a fairly basic setup before that kind of did the job. But the stock fuel lines and everything underneath have all kind of had it. They've always been a bit of a restriction, and more than anything else just look awful because they're all knackered and dragged. So when I repainted the car, I sort of ripped everything off. There's nothing left of any of the original pipe work. So the system I'm going to be running now will basically just be a lift pump in the back. The filter's all at the back. I want to try and move all that crap to the back of the car because there's not really room in the engine bay and it just looks untidy. So I'm going to stick a spin-on filter with a lift pump under the boot floor and then run two sort of modern fuel lines up to the engine bay where we'll have a swirl tank. So the fuel will just loop between the tank and the swirl tank and back to the tank on the return again with a lift pump on the low pressure side, and then the CP3 will be able to just suck clean fuel straight from the swirl tank and then return in there as well. The advantage of running that is you've got sort of a litre of diesel right there up by the pump all the time. The other advantage is if you do get any air coming up from the tank, the idea is you have your return on the top here, the pump intake at the bottom, and then your you return from your high pressure pump there and you send from your low pressure in the top here, or in the middle. It doesn't make much odds. So the air is naturally sort of forced towards the top of the swirl tank and should never hopefully end up going into the high pressure pump. So you should eliminate hopefully the air unless you suck the thing dry. There shouldn't be any fuel supply problems anyway, because I'm going to be running nice big fuel lines, a big hefty lift pump, so we should have plenty of fuel, particularly on this style pump, which doesn't actually return very much anyway because of the inlet metering rather than the outlet. So that's the idea. So the first thing we've got to do here is get this mounted in the engine bay. The original plan, what I had in my head, was I was going to mount it over in the driver's side wing here, just in front of the suspension tower. However, there really isn't room. I did measure it, I knew it was going to be tight, but I could sort of chop the floor out there and drop everything down, but I don't really want to have to do that. So I think what I'm going to do is actually sit it in front of the motor there between the pump and the inlet. There's nothing else going on there, so it can sit there and that can make the plumbing up to the pump nice and simple then as well. So I'm going to make up some nice little brackets. So just bolt one to the block there and one to the pump bracket for it to sit on. It needs to be easily removable in case I need to get in there for anything. So we'll make up some brackets for that first out of some steel. Right, we're kind of skipping ahead a little bit now. I forgot to do a video, but you can see I've just painted the two brackets I've made up just there so that they're just drying off at the moment. So we'll get those bolted up in a minute. So there's a left one and a right one, and then they just pick up on the holes on the bottom of the base plate on the swirl tank here. So that'll then bolt down, and the brackets can stay on the engine, and you can easily remove the swirl tank from in situ, and obviously the brackets if you need to as well. So that'll position that down there. And then we'll just need to run some hoses between it and the high pressure pump. The CP3's actually got a gear pump in it, so you don't need to pressurise the inlet on the CP3. This piece on the end of the pump housing there's actually a little gear pump in there, which is ideal. So much like a VE, it will suck its own diesel. So having the swirl pump right next to it will be ideal because it's got its own little loop. And then obviously you'll have a constant supply of fresh diesel coming up from the tank all the time, which will keep it happy and also keep the fuel cool. I'll have to have a fuel cooler on that loop somewhere, on the low pressure loop, just to cool the diesel off because they do tend to get a bit warm. Again, on these CP3 setups they don't get as warm, I don't think, or in my head they shouldn't get as warm as they do on the older common rail units where they meter the high pressure, because theoretically it shouldn't be making all that waste fuel from high pressure all the time. But time will tell on that. I will be obviously fitting a fuel temp sensor in one of those fuel lines, probably the one that actually feeds the pump, so we know exactly what's going into the pump. So I'll put a little fitting in line to allow me to put a sort of an oil temp or a fuel temp sensor in there. Right, so I just got that bolted in now with 4 bolts you can see on those 2 brackets we made. So now we'll just get some plumbing sorted. I'll sort the 2 lines from the swirl tank up to the high pressure pump, and then we've got the 2 lines to run right back to the back of the car. Right, so the first thing we're going to do now to this pump, in order to plumb that one up to the low pressure side of the fuel system, is get it adapted up so I can just connect my normal Dash 8 hoses to it. It's got these weird, funky, annoying push fit things, obviously from the factory application, which on this particular pump was actually a tractor. But I know a lot of OEM people like to use them. I'm not a massive fan of the things, they just get on my nerves. So, and they're also tiny. So we'll take that out, we'll measure up the threads, and we'll be able to replace them then with some Dash 8 connectors, and then obviously be able to just run normal hose out the back of the pump into the swirl tank then.
So you can see there now we've gone up to a -8 on the stand down and -8 on the inlet. I just do that because it's easy. You keep everything the same, you can make all the hoses up then.
And you can just run it wherever you want. So you can see in the vise here now, this is the fuel pickup out of the fuel tank, so that's a standard item. Originally when it was in the car, it used to have like a gauze filter on the bottom of the inlet, and the return would just dump back in the top. So in the last setup, when I was running the MTDI, we had a sort of HDI lift pump actually in the tank, cycling fuel up to the engine bay, which worked fine for what it was for. Now, there's probably nothing wrong with that setup. There's no reason why I couldn't use the same setup, to be honest, but I'm just trying to modernise it all. So what we're going to do here is, well, I've got a plan anyways, to lop off. It's a bit difficult when you've got like a plastic tank like this, because you can't weld fittings in the bottom of it or anything. So, and it's obviously a plastic top as well. I mean, one option would actually be have this piece here machined out of aluminium, which was actually something I considered doing actually, because it would be a lot easier to do this properly. But I'm going to avoid that for a moment. I can always do that if I have to, but the plan is to lop these off here and then use a compression style, sort of a bulkhead stroke fuel tank compression fitting to create a seal on here. The last thing you want to do here is make new holes and not have a good seal, because it all will be hunky-dory until you go and brim your tank for the first time. And then what happens is the contents of the filler neck drains out the top of your fuel tank and makes a mess everywhere and covers your car in diesel, which is not what you want happening. I do speak from experience there. So what we're going to do to start with is lop these two things off, and then we're going to come over, and I've got some fittings there somewhere you can see there with the extra threads. So you've got two -8 style fittings, but you've also got some extra threads here, so I can have a washer or a doughty washer or something on either side, or O-ring or something, and then get a compression sort of style fitting going on the plastic top here, which should then give me a seal and enable me to connect a -8 style hose on the top, and then we'll put a -8 adapter on the bottom into a half-inch compression fitting, and that will allow me to measure between there, the bottom of the tank, and I can cut some pieces of hard tube to make the pickup tube, and also the return. You want to stick your return down in the tank so it's below the level of the diesel really. Otherwise, when it's dropping back in the tank, it will put loads of air. If you imagine you're tipping water into a glass, if you hold the water above it, you'll see loads of air bubbles get introduced into the water. Well, the same thing happens in the fuel tank, and you don't want that, because you've got your pickup obviously sucking fuel right next to it, and you end up sucking a load of air, which you don't really want to be doing. So you want both of them going right under the bottom of the tank. Right, well, we've just been finishing off the fuel pickup now. So I think you saw in the last clip I made, I had the two elbows fitted to the top there. So obviously the plastic piece is all original, and then we've added these -8 fittings to it. So what I've done down inside the tank is gone from -8 down to a half-inch compression, and just used two pieces of half-inch aluminium tube. Cut off, these are 15.3mm out the end of the fitting, which gives us 0.2 of a mil less than it is to the bottom of the tank. I measured that from the lip of the tank down to the bottom, so we've got sort of half a mil clearance at the bottom, and just for safety there, I have just, if the camera will focus on it, I've just basically taken some diagonal cuts out the bottom of the tubes, just in case they're sitting a bit close to the bottom of the tank, to ensure that the fuel is still able to flow in through. You can just about see that. The camera doesn't like focusing very much today. So then I'll sit in the top of the tank. Obviously the original retaining nut can go on, and then that gives me this place to connect the fuel hoses in. Obviously the electrical connector is no longer used because the pump is now going to be mounted externally. So we'll get that fitted in the car now. Right, so I'm just going to drill some holes now. This is through the plate we're going to use to bolt everything underneath the car. I'm going to stick all this under the boot floor so it's nice and easy to get to the filter, and it's not in the way in the engine bay, trying to get all this crap out the engine bay if we can. So we'll bolt it on a sheet of aluminium, and then we can sort of assemble it all outside, and then we'll put some rib nuts in the bottom of the car, and this whole lot will just bolt up as one assembly. So it's nice and easy to drop. So these two holes will be for a bracket to hold the filter head on. So we'll do that first, then we'll go under the car and mark up where the mounting holes are going to be able to go. There's a chassis member that runs across the car back there, which is ideal for mounting on this. So we'll just get these two holes bored out a minute. Right, now just a few extra holes. I've been under the car and measured it, so I know where I want to mount it now. It's evenly spaced holes.
Okay, so we're back underneath the car here now.
So I've just drilled out those 5 holes along that cross member that I mentioned before, and put some riv nuts in there. So that's going to act as our sort of attachment point for this fuel plate that we're making up.
The idea being, this thing, if I get it the right way round, will bolt up something like that, and then I will mount everything to that. Right, that's bolted in now, so we can get the filter head and assembly all bolted up to that, and then the lift pump. Alright, so I've had a bit of trouble actually trying to find a fuel filter that's going to actually flow a half decent amount of fuel through it, and down at the sort of micron level that I want to run. So I wanted to run a 3 micron filter if possible now. We've obviously got on common rail. The injectors are incredibly sensitive, as is the high pressure pump and fuel pressure regulator, and really all parts of these modern fuel systems are extremely intolerant to any kind of crap in the diesel. There's lots of cases where vehicles have had crap going through the fuel, even if they've been going through like a conventional 10 micron filter, and I do think that probably is something to do with the wear that seems to happen, and also a lot of problems with FPRs and stuff. So I want to run a 3 micron filter. Now the problem I've had is trying to find a 3 micron filter with well, A, a decent size 3 micron filter, and B, one with the right fittings to attach to a slightly useful filter head that I can actually get some half decent flow through. So what I've ended up going for here is a man filter off a lorry. They also retrofit these to a lot of boats and marine stuff. I think I see these advertised for sort of marine use as much as I do for the original purpose. Now there's obviously the 4 original ports, 2 in, 2 out. They're fairly small from the factory. So what I've done here is, as you can see, is I've teed both of them so we can go in both of them and out both of them, with all these fittings on the top here. And I've also gone in with a drill and I've drilled all these fittings out as big as I possibly can without obviously disturbing the threads on the end here. So now we do have, well, the overall size of all the orifices in the filter head should now be larger than the hose, so there shouldn't be any restriction there, and the filter is a half decent sized filter. Obviously you can get longer filters again. I don't think there's going to be any problems like that, but I'm just trying to put this together so that we haven't really got anything in the system that's likely to be restricting it. So I've got that all together now, the filter screwed on. I've just made that little 90-degree plate there, which is going to bolt up to that piece of aluminium which you saw me mount in the car a second ago. Now then, the fuel pump will be mounted next to it. So it's just a conventional Bosch 044, as you see just about everybody using on all sorts of petrol and diesel applications. These flow a ridiculously decent amount of fuel really for, say, effectively a factory item off the shelf. Really easy to replace and not particularly expensive. Should be more than adequate for what we're doing here. The amount of fuel it moves, particularly as it won't actually be producing any pressure. It's really just going to be free flowing back to the swirl, up to the swirl tank, sorry, and back again. So it will flow like crazy at that kind of pressure level. So we've got, this is the inlet side down here. So we've got a 15 micron gauze filter at this end, which is the idea of that is to just pick up any of the large crap coming out of the tank or stuff, because the problem with 3 micron filters is they will clog real quick if you have like dirty fuel, because obviously they don't take any tolerances. So you want ideally to have a cleanable filter, or at least a pre-filter before that one. I have actually I still am wondering whether I ought to have a conventional sort of cartridge filter pre that one, just so that I'm not clogging this all the time. But I think we'll probably go with this for a minute and see how we get on. But I know all the tractors and stuff seem to have pre-filters and then the final filters, but the idea is to at least have this pretty fine gauze filter here to take out any of the crud, and that is actually one you can take apart and clean out. So it's not particularly fine, like I say, it is literally just to take out the major crap. It's basically a replacement to the gauze that's normally in the fuel tank. Obviously we've done away with that now with the new pickup, because it's a right pain in the ass having the gauze in the tank, because if you want to look at it you've got to take all this crap out, and it wouldn't have been massively easy to implement. So we've done away with that and basically relocated it onto the inlet of the fuel pump. So that's going to mount up next to it. I still need to get a couple of fittings here to come out of the pump. So it'll come out of the fuel pump around the corner into the filter head, and then the 2 lines will come up from there along the car up to the swirl tank in the engine bay. So I'll get under the car now and we'll bolt all this stuff up, because I've drilled all the holes in the plate now. So most of this stuff should bolt up, and then we can make the hoses up when I've got some new fittings and stuff. So I've got the pickup fitted in there now. So that just drops in the top of the tank as it did originally, and you can use the original seal and retaining ring to hold it down. The 2 fuel hoses then disappear off down the tunnel on the left there. Being phase 1 is ideal because there's a second opening in the tank for the fuel level sender,
which does make it a lot easier because you've only got the fuel lines over here to worry about rather than having it all in one unit. The bowl is also in the tank in these rather than being in the part that you drop in, which is again quite convenient for doing this conversion. Right, you can see I've got all the fuel lines all hooked up here now, so you can see the main send and return coming in from the back of the car there. So that's obviously off the back of a lift pump and the filter at the back of the car. Comes up to the the swirl tank, obviously the return goes back to the tank again. Then you've got the two lines here feeding the high pressure pump, and you'll just notice as well on the feed line we've got an extra fitting there. That's basically there so I can put a fuel temperature sensor in there. Just keep an eye on the fuel temperature, see what's going on, because I don't really know what's going to happen with that. I've got no cooler in line at the moment, but we may find we need one. Hoping with the bigger CP3 pump like this, with the inlet regulation, that we aren't going to need that. But we're going to put a sensor in anyway, so I can keep an eye on what's going on. Right, so now all the sort of low pressure stuff's done, I'm going to look at plumbing up all the high pressure fuel side of things to the fuel rail and the 4 lines up to the injectors. So I've had this line here made specifically for me because obviously we're running the CP3, which is sat in a completely different place to where the original pump used to be. So there's no way I could obviously use the original line because it would be nowhere near long enough because the outlet's actually on the front here. That is also the wrong fitting, so I had to have a custom line made. So what I actually did, because I haven't got any kind of equipment for making the flared ends on these common rail lines because they're extremely thick, obviously to handle the pressure. They're also extremely difficult to bend actually without a proper bending tool. So what I actually did was actually just bend up a line. This is just an old crappy inject line I had lying around, which I cut to the right length and bent up as roughly as I needed it, or as close as I could. I then posted that to a friend who does some diesel work, who has the equipment for doing this sort of thing. He then bent this one up and put the flares on the end. So this should now pretty much fit what I need. Obviously I can still tweak it slightly myself, but it's the hardest bit, all the tight bends and the flares are already done. So I should now be able to hook this up. So the first thing we'll do is we've just got some new inject lines as well from Peugeot for the 4 injectors, just because I didn't actually have the original ones for this engine, and I thought I might as well have new ones as go and find some second-hand ones. So we'll get the fuel rail bolted up to the engine first, and then everything else can kind of bolt to that. Right, you can just see I've got that line fitted there now, so that's the one that I had bent up just for this job. So I've got it hidden away quite well in underneath there, so it looks fairly factory if you look at it from a glance. Right, it's about time to get the injectors in now. So I've had these for bloody ages on the shelf, waiting to put them in. I didn't put them in before because I could see them getting damaged when we were sort of lowering the engine in and messing around with everything else. And they're quite an expensive item, so they've got left till kind of now. So it's a set of new 16 valve bodies and solenoids with bigger nozzles that I've chosen from another vehicle. So they should flow significantly more fuel, well they do flow significantly more fuel than obviously the standard items. So I've had these up and actually flow tested with a professional. I've got no way of testing these injectors, just due to the fact I've got no way of driving them. So I've had them professionally flow tested so that I have a full calibration table's worth of data, so duration versus pressure and how much they flow, which is fairly critical in getting your injector calibrations correct in the ECU. So I've had that done already. I've got it on a document on my computer, so I can get that going once we're up and running. But these are now ready to drop in and get all the lines hooked up. So I'm going to stick these in the engine now, obviously new fire seals and everything, and get these torqued down. So the first step here is just getting all the mounting hardware off the old injectors we had in before. Obviously because I was running it as a VE pumped MTDI before, I robbed all the hardware off the common rail injectors to secure the ones the hybrid injectors that I made up for that. So basically these 2 bolt hold downs that they use on the 16 valve, and obviously the retaining ring, that's all got to come off those injectors, which I've done now, and then obviously go on to these. I've just done one, so I'll just slide the other 3 on. So you've got the new fire seals at the bottom, the new plastic bushes that sit at the top, and obviously the nuts that torque them down. Okay, so you can see the injectors are all in now, the high pressure lines are all on, I've torqued them down, so they're all good. You can just see the fuel rail tucked in behind, that's the factory fuel rail for this engine, bolted on in the factory location, and then obviously the high pressure line coming up to the pump there, which I've made up for it. So really it's just the returns I need to put on the injectors now, which they run sort of all injectors connect together, and then I'll tee that into the main fuel return there on the top of the swirl tank.
And other than that, the fuel system then is pretty much finished. The only thing we just need to finish is putting a temperature sensor in there. I'm struggling to find one short enough, so I'm just working on that at the minute.